So I have these two relations, right? A relation is any time that you have an input, x, and an output, y, and they relate somehow. I have these two relations, and I just want you to think about a couple of questions. First question is, are either of these relations one-to-one? And if not, why are they not? And if they are, why are they? And the other thing I want you to consider is, are these functions? And let's look at this first one. It's not one-to-one, right? Because we have one-to-one, one-to-one, and then 3, 4, and 5 all go to 6. So that it's not one-to-one. But is it a function? And if we look back at our definition of a function, which is a couple of pages back, if we look at our definition of a function is a relation in which each input is assigned to exactly one output. Well, how many outputs are assigned to 3? Just one. 4, just one. 5, just one. They all have the same output, but they're still all assigned just one output. Okay, so it is a function. It's a relation, it's a function. Is it one-to-one? No. Because there are because if it's one-to-one, no two elements of the domain, so none of these elements map to the same element in the range. Whereas this one, we have 3 going to 6, 4 going to 6, and 5 going to 6. So it is not one-to-one. How about this one? This one, also not one-to-one, but is it a function? So here's the issue. 1 goes to 2, but 1 also goes to 6. And 5 goes to 6, and 5 goes to 10. So we have, if we were to write this in a table, right, we would have something like 1, which goes to 2, but we'd also have 1 that goes to 6. And this is not a function. And the reason this isn't a function, and hopefully it makes sense to you, is a function is we can plug something in for x, and then we have this function machine, and it will tell us what our y value is going to be. And this one, we plug in a 1, and we get out a 2 or a 6. So our machine is broken. It doesn't work. The machine doesn't know how to process the 1. If we put in a 1, it doesn't know to give us a 2 or a 6 because our 1 goes to both. And same thing with a 5. We don't know if it should go to 6 or if it should go to 10. And so it is not a function. For it to be a function, so this one is a function because even though these come to the different values, the machine's going to know, okay, if I plug in a 1, it's going to be a 2. If I plug in a 2, it's going to be a 4. If I plug a 3, 4, and 5 in, then it's going to be a 6. Okay, so plugging in numbers, even if the output's the same, that doesn't change whether it's a function or not. The only thing that does change is if it's one-to-one. Okay, so now for both of these, so this one's a function, this one's not. This one's one-to-one, this one's not one-to-one. It can't be one-to-one if it's not a function. Okay, that in mind, I'm trying to cover as many different little topics as I can in this one video. Let's write down the domain for either of these. The domain's going to be the same. And there's several ways to write the domain. If it's discrete, and we're going to pretend that this one's discrete, meaning that we can't have other numbers in between these ones that we've got listed, then if it's discrete, we're going to list out our domain. So this is 1, 2, 3, 4, and 5. Okay, just like that. And then our range, we're just going to list out our outputs. So 2, 4, 6, 8, 10. Okay, so there's our domain and range. If we were to have a continuous function, so let's just say we have y equals 2x plus 4. This is a linear function, and I can plug anything I want into, this is continuous, so I can plug anything I want into my x, and I can get out an output for y. So my domain is going to be negative infinity to infinity. And the way we write this is a rounded bracket or a parenthesis means that our number is greater than negative infinity and our number is less than infinity on this side. Okay, so this is less than infinity, this is greater than infinity. If we had a graph where we were limited, so if we had something like this and our line starts right here and goes like this, let's just say this is y equals 2. Okay, so our line doesn't continue this way. It starts right here and it goes up this way forever. So our domain, it includes this point, and when we're including it, we're going to put a square bracket. Okay, our domain goes from 0 and then it goes all the way out to infinity, right? So you're never going to have a square bracket with infinity because we can't ever get there. It's too far away. But we do have a square bracket with 0 because it includes this point. If we were not including the point, we would use a rounded bracket. And then our range, where does our range start? Well, it starts at y equals 2, and it also includes that one. So again, we're going to have a positive 2, and it's going to go all the way off to infinity. So our domain and range would be like that. I hope that this gives you an idea of domain and range and functions and one-to-one. A lot of the questions for this section and chapter are just identifying domain and range and whether or not something is a function, whether or not something is one-to-one, or if it's